In the last video, we ended up with, I would say, both a skeleton in the XZ, the YZ, sorry, and the XY planes, together with the full information in the cut sheet about the different cuts that we have in our plane. But in fact, the only thing that I've modified since last time is that I've added this the height, so the Z of the X-max to 115. How did I do that? It's fairly easy. If I take the YZ skeleton, I try to see, where is this kind of middle of the wing type of thing. Sorry. So here you can see that there is a kind of wing which is something like that. Okay. So first of all, you see that it's pretty horizontal here. Okay, and that the second point is that so it's easy to say, okay, at what level is it? And if you look at here, the level is 114 something, so I rounded that to 115. And in fact, this is how I filled to 115 here all the Z of the X-max. So that means that the elevation where the fuselage is the largest. Okay, we have that. But now I would like to share with you a little gem that I have in my template project. Which is I have some templates such as template for the cut, template for the wig profile, and template for the tail profile. So I will take that cut template here and I will copy it, just it, of course, and paste it. So I have my cut template here. I will explain to you a little bit what there is inside. So in fact, I will call that CutA, ASK, for example. And I will dive a little bit what's inside that template. So in fact, that's linked to one of the column here. So if I'm looking at the column B here, I see the cut template, and I have the same thing like, the Y cut, the Z bottom, the Z height, the X max, and the Z max, plus some ratio. And if I'm looking at that template, in fact, that's a template that is a single B spline. Of course, I've used that, so that means that, for example, this is the Z bottom, which is the B3 here, of course, and then I have something which is this height here. This height is in fact the Z bottom minus the Z of the X max, so that means that what is the height of the lower part of the fuselage, and then we're doing the difference with the Z height. I have the elevation or the height of the top part of the fuselage with respect to this axis here. So I have all that, and in fact, as you can see, this is fully constrained. So how do I do my spline? So this is a generic way of how I define cut profiles or fuselage profiles, fuselage cuts, and I will show you a little bit how I'm doing it. So here you have a spline, okay, because it's a single spline, and I will show you a little bit on this side how I am doing it, or how my template is constructed. In fact, 2, 3, 4, 5, 6, 7, 8. Okay, so this is a spline with 8 points. Okay, and now if I want, for example, those splines, of course, to be tangent in the middle of the fuselage, I need this by clicking on edge to be horizontal, and I need this by clicking on edge to be horizontal. Now I have a point in the middle, okay, of the curve, which is this one. And in fact, I want this point to be fully specified, because I've fully specified, I would say, what's happening. What did I do here? I want this point and this point to be symmetric as if it was fully specified. Okay, so I've done that, that's good. And now I want this point to be the maximum, I would say, width in a way. So in order to make sure that this constraint is always good, what I need to do is that I need to make sure that this point, and this point are vertical. I'm click on V, and that's a vertical point. And now, if you look well, I have only 8 degrees of freedom, which allows me, in a way, to fully define any kind of shape. I mean, provided that it's not completely crazy shape, you know, any kind of shape that correspond to some fuselage in a way. And so my 8 degrees of freedom, that's of course the height here, okay, the height here, the width here, the width here, and then the two position of that and the two position of that. Okay, and with that, really, you can define any kind of spline. The problem is that now, when I'm defining those things, I'm defining that with ratios with respect to, let's say, the height of the bottom part of the fuselage and the height of the top part of the fuselage. So the bottom part of the fuselage is, of course, the Z bottom minus the Z of the X max, okay, which is exactly that. So it's the Z of the bottom minus the Z of X max, okay. And of course, on this, I'm calling that local bottom height, okay. And here I have, of course, here the top height minus the local bottom height and the whole height, and that gives me something that I'm calling the top height. And then here I have something that I'm calling the local width, the local W. And now all the things that are into the horizontal axis here, they are defined as the local width times something in the cut sheet, okay, which is the ratio of the X of the top here, for example. This is the point number 1, and here this is the X1, and this is the ratio of the point number 1, okay. So that means that now, if I stop looking at this profile, but I'm looking at the cut sheet here, you see that I have the X top ratio, the X1 ratio, the Z1 ratio, the Z top ratio. So I will also explain to you what are those. So the Z top ratio is exactly this here, which is used here. So that means that the bottom, and the Z1 ratio is the thing that is used here. So the Z1 coming from the top, I would say, to the point of interest. And you see that this point, I'm not using the constraints on the constraints points, but really on the shape, in order to make sure that I, for example, fit onto a cut if I have that cut. So that's how this template is defined. And now we will look a little bit at the magic of that. So that means that my CutA for now is really, I would say, the copy paste of my template, but of course that means that the position is not good. So here, for example, it's not in the B2, but if I'm looking at A will be in the column E. So if A is in the column B, I would say E, I would say that this is here, sorry, this is E, E2. And now all my constraints that they are expressed here, they are expressed with respect to this cut sheet and the local constraints and everything like that. Now, of course, I've written a little macro here. So if I change everything and I say I want everything to be on E, then all of a sudden, yeah, of course, I forgot. So before you need to copy paste that, for example. Okay. And now all of a sudden, everything is good. And I have here my CutA, which is at the correct position, which has the correct, bottom, top, and which is okay in terms of in terms of height or X max and also Z of the X max. So I have everything. So now I need to, in a way, bring the cut, because you can see here that in my 3D views I have something which indicates the cuts. So I will import that cuts, and then we will see how to adapt this template. Now I will import the view. So I'm saying import, always the same file, okay? Now this file, of course, I will put it on the XZ plane, okay? Seems to be okay. Now I will transform it a little bit to bring it to the proper proper things, but in fact I will say that this is at 50. I will say that the position in Y is going to be at 20, for example, in order to see the shape of my plane here. Okay. And then I will begin to transform it or to calibrate it. So the calibration is very easy. It's this side here. I know exactly what it is. So if I look at cut, the Z8 is 18150. So in fact, if I'm going there and I'm asking to calibrate, I want this to be 18.15 meters. Of course, that's changed a little bit, okay, I would say. And now I can transform it to bring it closer to what I want here. Okay. So I've tuned the position of the cut to be in the good way, and now I need to adapt a little bit my template. This is really the template to this cut. So I will do something like I will change a little bit. I would say this thing here. I will show you exactly what I mean by that. So here, for example, if I see that this is not wide enough, so that means that I need to widen both the, I would say, X bottom on the X2, on the X of the point 2. And the X bottom is here, and the X2 is here. So X bottom, usually you see that if I put 0.35 instead of 0.30, that means only a difference of 5%. So you can see that it's pretty precise in terms of adjustment. Of course, you can spend hours on that. Usually I'm going from 5 to 5%. So here I will change that, for example, from 0.30 to 0.35, and here from 0.65 to 0.7. And you can see that here, this has already moved pretty much. I can see that I can go a little bit further, 0.40, 0.50, and 0.75, for example. And you can see here that I begin to follow pretty well the thing. So, where is it, my view? Okay. So I have this, which is okay. Now this point is a little bit, um, in a way, I cannot really play with the fact that this is going further than the cut. So the cut is not good in a way, and yet there is nothing that you can change with respect to that. So if I look at CutA here, for example, I can see that here I could go down a little bit more here. So instead of 0.10, I could go to 0.2, for example. And if I'm clicking on that, it's gonna be updating itself. And well, besides that, it seems that I'm not too bad. I can eventually increase that a little bit, but not sure. Yeah, 0.55. Okay, and here I have that, this 0.55. So now I have this thing here. Is that good enough? That's not too bad. If of course I am obliged to take on the constraints that I have the width that is imposed, in fact. And again, this cut is not good. So I have my cut A here, and you can see that it took me roughly only a few minutes in order to have my cut A. And now, if I have my cut A, I can start from here in order to have my cut B. And the only thing that I need to see is that, okay, of course, I've loaded the cut B here. And what I will take is that I will take my template, Control C, Control V in order to have that. That's going to be my cut B. Cut B, not G. I don't know. Okay. Of course, I have to change that. So B is in the column G. Yes. So that means that here I'm going to be in G2. And again, I have my little magic macro here. So if I select that CutB and I apply my macro to change all, and I say now it's column G, all of a sudden I have my CutB here, which is good. Again, we are going outside of the view of the cuts, but that's because the view of the cuts is not compatible with, for example, the top view and whatever. You can see here that, of course, it's a little bit too much. So 0.45, for example, that's since too much. So 0.30, for example. Yes, and here 0.55. Okay, and now we are a little bit better for all that. I can play also, I can say that this could be here. Yeah. I can eventually say that this is 0.80 here. And now if that's a little bit too much, I can say that here it's a 0.50. I'm trying not to move, I would say the Z, okay, just to move the X in a way. But you can see here that I'm creating something which is not very good here. And so that means that if I'm looking at that, I can see that it's a little bit too constrained, and it's not really a smooth curve. So I will have to change that a little bit. So either I diminish that in order to have something smoother, okay, but that's not working too much. So here 0.1, so that's a constraint that I have that. Okay, my that means that the either this or this is too big. So here I will put 0.40, like for example, and perhaps 0.35. Okay, now of course that means that this must change a lot to 0.7. Okay, but you can see here that it's not really smooth. So you have to play a little bit with those things in order to make sure that you can have something smooth, okay, because that's fairly important. But in order to keep the ratio here on this value, you need to play with those value, which is the thing that I will continue on working, and then I will come back to you in order to show you that everything can be done. I thought it was interesting to share with you the adaptation to the CutD, which is a little bit, a different shape. So I have here my CutD, which is really the default. And now I click on my little macro in order to get the column K. Okay, so I have this start here. And in fact, if I'm looking at that CutD, the only thing that I need to make sure is that this point here should be much closer here. So like perhaps a little bit less than half. So it's very easy. I go to the CutA and the x1 ratio should be aft. So something like 0.32 or something like that. And now if I'm looking at the CutD, I see that this is going to be pretty much okay, except that I need to go a little bit higher up in terms of Z ratio. So that means that the Z ratio, instead of being like 25%, should be like in the 30s or something like that. So that's exactly the thing that I'm going to do here. So that means here, instead of 0.25, 0.35. Okay. Now, little by little, I'm approximating, I would say, this, like saying that this is not 0.2 but 0.5, for example. And all of a sudden, I have something which looks more and more towards what I'm looking for, and that's a little bit this idea here. So 0.40, for example. And now I think that I'm gonna leave it like that. So that's something which is interesting. Another interesting thing is that this cut end here is really small, like the X max of 0.1 millimeter, so 1/10 of a millimeter, and the height is 0.2 millimeter only. The thing is that if you just take like a regular profile, like the profile C, for example, in that case, you do it's column M, Control C, Control V. So that's the cut end SK, okay, which is in column M. Okay, and now if I'm taking this and I am adapting, so I select that and I click on A and I say this is column M, all of a sudden everything is done. And really, if I'm looking at that, you see that it's a very, 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 very small cuts, but I do not have any problem having it, okay? So now there is one that I didn't do, which is yet the cut 1. So this is the cut 1 SK. So I need also, let's say, to take, I will take the thing like the cut A as a template, okay? And then I will adapt it to the cut 1. So that means that if I'm selecting the cut 1, so the column is C, in fact. So if I'm taking the cut 1 with my macro, and I say that's column C, then I can just, adapt a little bit. But in order to see it, I need to see the front view. Okay, and the cut 1 is here. And now I can see that I need to diminish a lot this here. So instead of 0.5, that's 0.25 or something like that. And now if I'm looking at that, that's 0.5. Oh, that's a little bit too much. 0.6. And now I think I'm pretty good, okay? So that means that in 2 operations now, I have that which is already done. and this is in the position not E2 but C2. And now I can look at all my cuts, and you can see that it has taken me a very small amount of time in order to do it. Now I know that everybody would like to have fun in a way. I can save it, always save it from time to time. Okay, and now in fact if you want to play, you can do a loft between the cut 1, A, B, C, D, and click on OK. And normally, with a little bit of luck, you have your first, I would say, shape of the plane as it is here. And look, we have here a loft of degree 5, okay? So a loft of degree 5 is very prone to kind of wrong perturbation or something like that. And you can see here that it's pretty smooth, okay? It's pretty good. If of course I'm looking at the top view, I see that I'm following that profile. Now if I'm looking at the right view, I do not follow that profile, but that was not completely, I would say, expected in a way. But I will see that I will need to add certainly something here in the middle and something here in order to control those things. But the good news is that with the technology that I have, adding a new cut, as you can see, is absolutely of no issue. So the process of adding new cuts is pretty easy. Basically, I'm going into the YZ skeleton and I'm creating, you see here, these construction geometries, but that correspond to the CD line. Also here to the end in order to be able to control this kind of curve here, and also in the middle the separation between the front fuselage and the back fuselage, and that I've called of course I've called that BC, and this I've called that CD, and this I've called that F. So it's very easy. Now you go into cut SH, and you know that I want to create a cut BC here, a cut CD here, and a cut F here. So how do I do that? I take all that. So that's going to be the cut BC. And as usual here, Y BC, easy, Z bottom BC, Z height BC, X max BC, you see? And that's going to be the same thing here between C and D, CD, pretty easy. And the same thing here for the cut D. I will call that the cut F. And here that's the cut CD. And here that's the cut BC. So cut F, so that's YF, ZBF, ZHF, X max F. I've missed one line here. So let's see in the XY skeleton. F, yeah, I missed it. Okay, so I will add it. So I have one here, so it should be around here, close to here. Okay, I say that this, and this are symmetric. Okay, I say that in terms of height, this is YZ skeleton constraints YF. Okay, and now I have to pick a little bit. As you can see here, there is a big discrepancy between the top view and the back view. So I will not solve that for now. I will just say here that's this here at 20. That's the X max F. Okay, and now all of a sudden this should be good now. Yes, and so I'm all good. In fact, the cut BC here between B and C should be close to B, so I will copy that and put that here. The cut CD should be close to the cut C because and the cut F should be close to the cut D. Okay, and now very easy as usual. I will take the cut D, Control C, Control V. This is the cut F. And now I'm taking that, and the cut F is in the column L. So cut F, I'm applying my macro with L. And of course, I put that at the level of L. Okay. Now I have my cut here. C, Control C. This is the CD. CD is in the column G. J. Okay. And so I take that, apply my macro with J, and I have that here. Okay. And this I have my BC here, and that's GH. And I take that, I apply my macro H. Okay, and I have everything here. So now I can, for example, redo a loft just for the back. So the loft for the back would be, in fact, clear. It's going to be the BC, the C, D. No, sorry, clear. BC, C, CD, D, F, and OK. So that's going to be the loft of the back, in a way. That should be like that. Okay. So as usual, there are some little things to be tuned. Okay, but that gives you a little idea. And the loft for the front should be a little bit more like cut 1 A B B C. No, 1 A B B C, and then that should be okay. And this is the cut for the front. Now, of course, it's not exactly like that. I will show you a little bit how I'm doing it, but that's to give you an idea. Also, the fact is that now you begin to see, but there is too much constraints here, but you begin to see a little bit how things will build up. Looking back, I think I should have taken another plane in order to have this kind of, let's say, course, because it's a pretty complex shape in a way. I will show you that. So At the end of the day, you have several parts in order to define the fuselage, and in fact, you need 4 parts. So I've put all of them here. So first, the front skin. So the front skin is okay. The only little thing is that I had to create a B inflated, an AB inflated kind of things, because if you remember, in the shape, there is a kind of, let's say, distinctions between the engine cover here and the regular fuselage. So if you want to have that, of course, that means that you need to have an AB inflated, which is a little bit different from the AB here. So you need to have 2 different lines here. Now, of course, with the same techniques, AB inflated is kind of easy, because the only thing that you need to do is that you need to lower a little bit the bottom by, for example, 0.9 millimeter, and you need to make the top a little bit higher, like 1.2, so that means 0.23 millimeters on top of what it used to be, and then you have to have a width which is a little bit wider again of 1.2 millimeters. And that's how you create the AB inflated, and that allows you to have the front fuselage in a way. Now the same thing for the middle. The middle skin, it's something which is a little bit like that. You need to go on if you want to make sure that there are a kind of, let's say, continuity between the part of the rear part of the fuselage and the middle part of the fuselage. And so this is why I had to create something which is a C front, which is a little bit like the C, but at the level of the cut here, in a way. And then, of course, you have to create the rear skin. So the rear skin is the one that is the most complex. At the end of the day, I had to create a kind of number of, let's say, cuts in order to get there, as you can see. As you can see here. So that's, oops, that's this thing here. Okay. So I had to create a number of cuts in order to get there. Now, I was not completely, so in fact, the first thing is that I needed to create a cut here, which is a little bit higher, in order to control the fact that this curve here would follow after the cockpit exactly the curve that I was looking for here. And this is also why I had to been obliged to create this line here, so which is the DDE line in a way. So as you can see, that's many curves that I had to create. So this is why having the template allows you to do so. So that's cool on one side. But on the other side, you obtain something at the end which is like that, which is pretty smooth, which is something that I want. Okay, I want to keep the smoothness of the thing in order to get there. Now, to tell you the truth, that was not completely satisfied with that. Why? Because in a way, I begin to go a little bit further, but I've created some tools which will be the things that I will use in order to cut, I would say, my shapes at the end of the day. So that's the cut of the cockpit, the cut of the rudder, and the cut of, let's say, the fuselage in a way. And if I'm taking that shape here and I do a cut with that, first I will show you something, which is the fact that, yeah, well, okay. So if I take that shape here and I cut the canopy, doing a cut, and from that cut I cut the rudder, doing another cut. I have something like that, and then I can cut that with a fuselage. That's going to be the one that I will keep at the end of the day. So at the end of the day, I will keep that in order to make my shape in a way. The little problem is that at the beginning, this was not good enough. So, for example, if I take that cut and I'm going into View, Draw Style, Wireframe, I see here, okay, my shapes. And in fact, to tell you the truth, I had to change a little bit this profile here in order to make sure that I'm following this line here. But if you look here, that's not good at all. I mean, it's clear that here there is a curvature here that is not present in the original plane, and that can be seen because, for example, if you look at that, you can see that this is kind of pretty straight here, and that means that here there is a kind of really sharp thing coming out. So I had to do something around that. And in order to do something around that, I had to change a lot the profiles that in fact are in close to this shape. So that means especially the D and the DD and the E. That's the profile that I need to change in order to go much straight here, in order to have a kind of then after that a kind of let's say extension or bimp or burp or whatever, I don't know, but in order to follow that line here. And that's something that I had to do. And for example, I will show you the DDE. So I had to change that, of course. And I had to change that into the T2, for example, with the DDE corrected. So as you can see here, the DDE corrected is something which is much wider. In order to do that, I had no choice than to create another knot in my B-spline. So my B-spline, instead of having 8 knots, has 9 knots here. And in fact, to position that knots, in fact, I've used a kind of straight line here in order to make sure that this point here in the curve and that this constraint here, so this construction point for the spline, was completely aligned, and then I could go a little bit, you know, on the wide side in order to create that that kind of convex concave shape that I had to do that. And in fact, so if now I'm taking that fuselage here and I remove the rudder, so cut here, you will see that if I'm looking that at the top, now I have something which is much closer to the shape that I wanted. But I can tell you that this was a kind of big battle in a way. And then after that, I had to look at a little bit how was my shape in a way. And I figured that this shape was a little bit too much constraints here. So in fact, what I had to do in order to remove that constraint, okay, I had to finally remove the the cut D completely by just, you know, going from the DD, the CD that I created to directly the one after that. So that's how I've done that in order to make sure that I have the smoothest, I would say, uh, curve shape in a way. And that was, as I told you, a little bit a battle to get there. And also the last point that I have is that I had to create a tip. Of course, I will not keep it. I will cut it here. I had to create a tip because if I was including that tip into all my curves here, that was generated a lot of, I would say, bumps and artifacts that I didn't want, so I kept the tip separate here. And that gives you a little bit why I've how I created all that. Now, a little comment about the fact that when you create cut, you see that you are losing track about your objects when you're using a part, and you can see that I'm using part and not part design, because it's really, part design is really well suited when you have a kind of linear design process. Now when I'm doing my projects here, of course the thinking process is absolutely non-linear. And so in order to be completely free and to use all the options about the cuts, the intersections and everything like that, I need to use part. The problem with part is that as soon as you do operations, you lose track about your about what you were using. So in fact, what I'm doing is usually is that I'm having those important shapes that are the shapes that I will use a little bit later in order to go further, and I'm cloning them directly. And so that means that now, whatever I'm doing with those, uh, so I keep that in the fuselage skin. So whatever I'm doing with, like the fuselage rear skins and everything like that. So for example, I will take this rear skin and I will do exactly the same thing that I've done. So that means I will cut my rudder, and then I will cut my canopy and everything like that. And let's say that, for example, this cut now is completely lost in my hierarchy tree like that. Okay. So the good news is that if I want to, whoops, I want to not show anything there. If I want, for example, to remember where is my rear skin, okay, I click on that, and here I have my object original. Okay, so I can retrieve very easily into the object tree where it is. And this is, I think, not by default. So you have to go to Preference, and in the selection, you have to make sure that those checkboxes are ticked in order for you to be able to retrieve your objects very easily. Okay, that was it for now. So I finished the fuselage in a way, and now I will go on with the wings.